Alright, I'm going to show you how to create your Discovering Density lab from scratch. We can create the data table. We're also going to be able to create the graph that is associated with it. First thing I want to do is to go to Google Drive, and in Google Drive I'm going to create a new sheet. I hit the New button, choose Google Sheets. Alright, I'm going to now title my lab. Let's change this to Discovering Density Lab. I'm going to give a title to my table here, Discovering Density. And now I need to put in the header information from my lab. So first thing I ask you to do is indicate whether it was silver or gold. So I'm just going to type that in there. In the next cell in C3, I'm going to write sample. In the next cell, I'll have the volume initial. And that's measured in cubic centimeters. I'll have the volume final. That's also measured in cubic centimeters. I'll have the volume of the sample. That's measured in cubic centimeters. And I'll have the mass of my sample, which is measured in grams. So far, so good? Because these are headers, I want to make them bold. So that you select the cells that you want, and then you can make them bold. Alright, and then I think I'm going to make my title a little bit larger. So I'm going to make it bold, and then I'm going to change the size by going to font size. 18 looks good. What do we do about cell D3? Do you notice that not all of the title or the header is showing up? So if you want to adjust the header, the width of the column, you go to the line that's in between columns D and E. You'll see a little blue line pops up there. Okay, I can adjust that by dragging it left or right. Or you can auto adjust by double clicking on it. That's what we're going to do. I'll do the same thing for these other ones as well. Alright. So my sample was silver looking. And it's trying to autofill here, so if you see that it has the silver and the gold, you can just delete anything that's in blue. I'm going to put sample 1. I'm going to enter the volume that I measured in the laboratory, which is 14.9 for me. Use your volume. I'm going to put in the final volume, 16.5. I'm going to calculate the volume of the sample, and I'll show you how to do that in a second. And I'm going to get the mass, which I measured to be 12.46. So all of my samples were silver, right? So one of the things I can do if I need to repeat the same entry in multiple cells is I go to the corner of the cell, and you see the little square box in the corner? We're going to drag that down. It's going to autofill for us. We don't want to do the same thing for the sample number 1 because it will fill in number 1 in all the boxes. So I'm going to type in number 2 here. But what we can do is highlight those 2 cells. Once you have a pattern established, the computer will recognize that you want to go 1 through 5. So that's why I dragged that box down there. Okay, we said that the initial volume for all of our samples is identical. So I'm going to drag that down so it's at 14.9 there. I'm going to type in all of the sample information that I have for my other samples. So sample 2, I had 18.6 was the final volume, 20.6 for sample 3, 22.4 for sample 4, and 24.1 for sample 5. Okay, my masses, I already have 12.46 in for sample 1. Here's my other values, 28.94 for sample 2, 45.18 for sample 3, 59.33 for sample 4, and for sample 5, 72.17. So I mentioned that you can let the spreadsheet do a lot of the work for you. To get the volume of the sample, we take final minus initial. And the way that we can do this in our spreadsheet is we hit the equal sign, okay? And now you'll notice up here where it says fx, that's a function, and it's letting me know that I can do some math. So I'm going to take the value from E4, and I'm going to subtract the value from D4. And it tells me it's 1.6. One of the advantages of doing it this way is I only need to perform a calculation once, and the computer can do the rest of the calculations for me. So when I drag the little corner down here, it will recognize that I wanted to do the same thing for the next row. I wanted to take what was in column E and subtract column D from it. So now I've got all my samples. All right, let's make our table look a little bit nicer here. Select our entire table, and we're going to put borders around the cells. So we go to where it says borders, we click on that, and I'm going to click all borders. Now I've got borders around everything. Okay, in the sample that I showed you, I also included a sample 0. And we didn't do this in the laboratory, but sample 0 is going to be necessary. When you have 0 sample, you'll have 0 mass, and that will show up really nicely on our graph. So what I'm going to do is select row 4. I'm going to right-click on it, and on your Chromebooks, you double tap with 2 fingers, kind of like we call it the snake bite. So 2 fingers tap, and then we are going to insert one above. And now it's saved all of my formatting that I had for the other one. So let's quickly figure out. We're going to put in silver. I'm going to put in sample 0. The initial volume was 14.9. If we haven't added any metal sample, its final volume will be 14.9. And I'm going to go and copy that formula that I had for the volume of the sample and put it in the cell above. So I'm just going to go to cell F5, Control C, copy. Cell F4, I'm going to paste, so Control V, paste. And there's no metal added, so the mass is 0. So now you're discovering density table has all of the information from your laboratory. Next thing that I did was calculate the density. And to calculate the density, I needed to take the mass of the sample divided by the volume of the sample. So let's create a new column heading. Density. And density is measured in grams per cubic centimeter. And then I'm going to bold that. All right. And I'm going to make this a little bit bigger. And you'll see why here in a second. We are not calculating the density of the sample at sample 0 because we don't want that to influence our average density when we do that calculation. So I'm just going to put a dash in here. Oops, let me get in there. All right. So I'm just going to not calculate anything based off of sample 0 for density. All right, so density is mass divided by volume. Let's create another function. I'm going to hit the equal sign. I'm going to take the mass value that I want in the numerator, and then I'm going to divide it by the volume of the sample that I want in the denominator. So in this case, my function is equal sign G5 divided by F5. So I want to do the same thing for all the cells underneath. I'm grabbing the little square, and we're going to have it calculate the density there. Now, I don't want all those digits. I only want to go to the hundredths place. So I'm going to come up here, and we are going to adjust the decimal places. So if I want to make the decimal places bigger, I click on increase decimal places. If I want to make them smaller, I'm going to decrease the decimal places. So we're going to click on that until I have 2 decimal places. All right. So I want to make this look nice, just like the rest of my table. So I select those cells, and you can hold down the Shift button and when you're trying to select things. And I'm going to put a border around those as well. So now we're going to calculate the average density. Average density. Can't spell. Okay, and that is in grams per cubic centimeter. Okay, so this is the average density in grams per cubic centimeter. Did you see how I adjusted my column because my cells were not fitting where I want them to? So let's double click on that. So now I've got that underneath. The average density. Well, we know that the average is taking all of the samples that we're interested in, right, and dividing by the number of samples present. So I could take what's in cell H5 and add it to H6 to H7 to H8 to H9. I get a sum, and then I divide that by 5. So I could do that in my cell, or we can take advantage of a special function called average. So I'm going to hit equals. I'm going to type in average, and you'll notice that it gives me some options for functions, but this is the one we want here. You're going to use the open parentheses, and then we're going to select the cells that we want to average. So I'm going to click on H5. I'm going to hold down my Shift button, push down until I've selected all the cells that I want to average, and then I'm going to close the parentheses. And there's the average density for my sample. All right, the next thing that you need to do is to take the deviation from the average. So deviation from average, and that will also be reported in grams per cubic centimeter. So that's a column heading, so let's bold that. Let's make this bigger. Okay, I'm not going to calculate the deviation from sample 0, so I'm once again going to put in a dash there to recognize that I'm not going to use this data in my graph. So the way that we calculate the deviation from average is we take the value of our sample, we subtract it from the average density in this place. So sample minus average, and then we will take the absolute value of that. So we just want to know how far we're off from 7.86. So let's set up a function to do that. So I'm going to hit the enter sign, then equal, open parentheses, okay, oops, sorry, delete that parentheses. We're going to use the absolute value here. So ABS is absolute value. Now open our parentheses. We click on what we want to take the absolute value of. I want cell H5 minus cell H12 because that's where my average density is stored. Okay, close parentheses. Now, just because you're not used to using spreadsheets, when I copy this formula down, it will not only adjust H5, but also H12. I need to lock cell H12, so that it's always subtracting from H12. And the way that we do that is to put a $ in front of the row and a $ in front of the $sign in front of the column and a $ in front of the row. So instead of H12, we're going to have $H, $12. All right, I don't need that many decimal places, so I'm going to once again decrease till I have 2 decimal places, just like I did for the density. We are going to take that corner, drag it down, and now it's calculated all those values for me. I like spreadsheets. It makes it so I have to do less work. So let's make this look pretty. We're going to highlight those cells, and I'm going to put boxes around those too, so now they're included in the table. All right. You now need to calculate the average deviation. Okay. In grams per cubic centimeter. Let's bold that. So the way that we can do that is take advantage of the average function like we did in the last problem. So intersign equals, let's select the cells we want to average. We're going to take all those deviations, select I5 colon I9, and then we're going to close the parentheses. I need a parenthesis on both sides. Oops. Sorry, I guess you don't need parentheses on this one. Alright, so I messed up a little bit. We are taking average, right? So we do need to write an average, open a parentheses, I5 colon I9, close parentheses. Alright, now I should have the value here. Very good. So these are the values that I would like to report in my laboratory conclusion. So I'm going to highlight them and then put boxes around them as well. So if I were to report this in my final spreadsheet, I might do some, or my conclusion, I might do something like this. So I'm going to put enter, and I'm going to put 7.8. Can't type 7.86. If you're on a computer, you can type Alt 241. That gives you the plus or minus sign. It's a little bit harder to do on a Chromebook. So you could also do this, right? Plus slash minus. Oop, I messed that one up, didn't I? Plus slash minus. So you could do it that way as well. So your choice. And then I'm going to put in the average deviation, which was 0.05. The units of density were grams per cubic centimeter. Let's highlight that with the box. So our table's looking pretty good now. Okay, the next thing we want to do is type in our period. I'm doing this before school, so I'm putting in period 0. And my group members. So there's Mr. C. Okay, and because I was working with myself, I'm just going to copy down that Mr. C. All right, this is a completed discovering density table. So you guys are doing good so far. The next thing we want to do is to create our chart, and this takes a little bit more effort. So I will include that in the next video.